A trail camera does not know it is filming history. It just sits there, strapped to a cypress trunk in the Big Cypress National Preserve, triggered by motion, indifferent to meaning. But when biologists pulled the memory card from one of these cameras last year and played back the footage, several of them stopped what they were doing. Nobody in the room was cheering. Nobody was panicking either. They were staring at something that did not match any of the models they had built over the last 2 decades, and they were trying to figure out what it meant. To understand why a few seconds of grainy night vision footage could do that to a room full of seasoned field scientists, you have to understand what the Everglades actually is, what was done to it, and what has been quietly happening inside it while most of the country stopped paying attention. The Everglades is not really a swamp in the way people picture swamps. It is a shallow, slow-moving sheet of water, sometimes only inches deep, drifting almost imperceptibly south across a sawgrass prairie the size of a small country. For thousands of years, it functioned as one continuous organism, filtering the drinking water for millions of South Floridians, buffering hurricanes, recharging the aquifer beneath the peninsula, and hosting one of the densest concentrations of wading birds, alligators, and mammals in North America. Economists have tried to put a number on what that system does for free, and the estimates run into the tens of billions of dollars a year, none of it coming from ticket sales or gift shops. That system ran largely undisturbed by outsiders until the final decade of the 20th century, when 2 very different events collided to change everything. The first was a storm. In August of 1992, Hurricane Andrew tore through South Miami-Dade County as a Category 5 hurricane, one of the most powerful ever to make landfall in the continental United States. Among the thousands of structures it leveled was a reptile breeding operation on the edge of the Everglades. When the walls came down, an unknown number of captive Burmese pythons escaped into the wetlands. The second event was slower and far less dramatic, which is exactly why it did more damage. Throughout the 1990s, Burmese pythons were sold cheaply as novelty pets. A hatchling is small enough to coil in a child's palm. Within a few years, that same snake can weigh more than a grown man and stretch longer than a canoe. Thousands of owners who had not thought that far ahead eventually found themselves with an apartment-sized predator they could no longer house, and the easiest exit was a drive to the edge of the wetlands and a door left open in the dark. Multiply that decision by years of unregulated reptile trading, and the hurricane escapees stopped being the main story. They were simply the spark. For a long time, almost nobody noticed. Pythons are ambush predators built for stillness. Their mottled scales dissolve into dead grass and tannin-stained water. Heat-sensing pits along their jaws let them detect a warm body in absolute darkness, and they can hold their breath underwater for the better part of half an hour. A raccoon walking the edge of a slough has essentially no warning before it is inside a coil of muscle that can weigh more than it does. The Everglades gave these snakes everything they needed to thrive: year-round warmth, abundant water, and a population of native mammals that had spent millennia evolving alongside alligators and panthers, not a heat-seeking constrictor from the other side of the planet. With no natural predators of their own, and clutches that can top 100 eggs at a time, the python population did not creep upward. It went vertical. By the time researchers formally measured what had happened, the numbers were difficult to process. Nighttime road survey data compiled by federal wildlife biologists and published in a major ecology journal found that raccoon detections in the hardest-hit parts of the park had fallen by well over 90% compared to pre-invasion counts. Opossum sightings dropped by a similar margin. Bobcats fell by more than 80%. In some survey routes, marsh rabbits, foxes, and white-tailed deer simply stopped appearing at all. Researchers who had worked the park for decades began describing long drives through habitat that once teemed with movement and finding nothing. They started calling it, informally, the quiet. Current estimates put the python population somewhere between 100,000 and several hundred thousand animals spread across South Florida, a range wide enough to tell you that nobody actually knows the true number, only that it is large, and that the snakes have become extraordinarily good at not being found. Florida did not sit still. Wildlife agencies launched public hunting competitions with cash prizes, paid professional contractors to walk transects with radio-tagged scout snakes that lead hunters to breeding aggregations, tested thermal drones, and even experimented with robotic decoys designed to lure snakes into range. Since 2017, contracted hunters have removed tens of thousands of pythons from the ecosystem. And yet the math never worked in humans' favor. Removing even 20,000 snakes from a population that may number in the hundreds of thousands barely dents the total, and pythons, it turns out, are not passive about the pressure. Field teams began noticing that trapping sites which had produced snakes reliably for months would suddenly go cold, not because the population had crashed, but because the animals still there had shifted deeper into terrain that humans struggled to reach on foot. Whether this reflects individual snakes learning to avoid human scent trails, or simple natural selection quietly removing the least cautious animals from the breeding pool generation after generation, the practical result is the same. An already elusive predator has become harder to find without anyone training it to do so. While all of this played out in public, something far smaller was moving through the ecosystem almost entirely unnoticed and would ultimately prove to be more consequential than any drone or bounty program. Around 2012, University of Florida researchers performing routine health checks on native snakes began finding animals in visibly poor condition, thin, weak, breathing with obvious effort. Dissections revealed the cause. Packed into the lung tissue were dozens of small, pale, worm-like organisms, technically a type of crustacean parasite called a pentastome, feeding on blood and physically obstructing the airway. The species was identified as Raleighidiella orientalis, an organism native to Southeast Asia that had never before been documented in North America. It had arrived, almost certainly, inside the lungs of the same Burmese pythons that had been quietly colonizing the wetlands for years. Pythons, having evolved alongside this parasite for a very long time, tolerate it reasonably well. Florida's native snakes never had that chance. The way it spreads is what makes it so hard to stop. An infected snake sheds parasite eggs in its waste. Cockroaches and other invertebrates ingest that waste and pick up the larvae. Frogs and small lizards eat the roaches. A native snake eats the frog, and once inside a new host, the larvae do not stay in the digestive tract. They burrow through the stomach wall and migrate directly to the lungs, where they mature, feed, and reproduce, filling the airway until the animal can no longer breathe properly. Wildlife biologists working on the Snake Lungworm Alliance and Monitoring Project, a collaborative research effort launched in 2022, have documented dozens of dissected snakes with heavy infections, some carrying well over 100 parasites in a single set of lungs. Since that first 2012 detection, surveys have confirmed the parasite in at least 18 to 19 native Florida snake species, from banded water snakes to pygmy rattlesnakes, and has been recovered as far away as counties in the northern and central part of the state, hundreds of miles beyond the python's own range. That detail matters more than almost anything else in this story. The parasite no longer needs a python nearby to spread. It has become fully capable of moving from native snake to native snake on its own, through the same insect and amphibian relay it always used. Even in a hypothetical scenario where every python in Florida vanished overnight, the lungworm would remain, embedded permanently in the state's snake populations. There's one genuine bright spot buried inside this grim picture. Across repeated field surveys, one common native species, the Florida cottonmouth, has turned up strikingly free of infection compared to the snakes living alongside it. Nobody has fully explained why. It may be immune physiology, it may be something about blood chemistry or venom composition, or it may be a combination of factors nobody has isolated yet. But a species that appears naturally resistant to a parasite this aggressive is not a minor curiosity. If researchers can eventually identify the mechanism, it could open the door to protecting other species that have no such defense. Against that backdrop, Florida wildlife officials announced a plan that struck a lot of people as baffling on its face, releasing more snakes into the wild. Social media reaction was swift and largely mocking, understandably, given the state's recent history with invasive reptiles. But the species involved was not another import. It was the eastern indigo snake, the longest native snake in North America, capable of reaching lengths approaching 9 feet, with scales that shine an iridescent blue-black in direct light. Unlike a python, the indigo does not constrict. It is a snake-eating specialist that pins prey with raw jaw strength and swallows it while still alive, and it carries a natural immunity to the venom of every pit viper native to the region, meaning rattlesnakes, cottonmouths, and copperheads are all viable prey rather than threats. The eastern indigo was never wiped out by a predator. It was wiped out by habitat loss. The species depends heavily on the burrows dug by gopher tortoises for shelter from Florida's summer heat and its occasional winter cold snaps. As longleaf pine forest and scrub habitat across North Florida were cleared for agriculture and development through the middle of the 20th century, gopher tortoise populations collapsed, and the indigo, unable to survive without their burrows, disappeared along with them. By the late 1970s, the species was functionally extinct across most of North Florida. For decades, conservation groups worked quietly to reverse that, breeding indigos in captivity, restoring longleaf pine habitat, and reintroducing gopher tortoises to prepared sites, most notably at the Apalachicola Bluffs and Ravines Preserve, laying the groundwork long before any snake was ever released back into the wild. Then, in late 2023, a trail camera at that preserve captured something the research team had been working toward for half a century. Two small eastern indigo hatchlings moving through the underbrush, animals that had not been released by any biologist, but born in the wild to parents that had. It was the first confirmed wild birth of an eastern indigo snake in North Florida in roughly 50 years. Researchers on the project reportedly reviewed the clip more than once before picking up the phone to tell colleagues. Meanwhile, in the South, something else was shifting. For 20 years, the food chain in the Everglades had run in essentially one direction, python at the top, everything else absorbing losses. Then field biologists tracking a radio-tagged python found the animal dead, its head crushed, on a trail camera that had recorded the entire encounter. The killer was not another python, and not an alligator. It was a bobcat roughly half the snake's weight, which had apparently stalked it and struck at exactly the right moment. That incident was not an isolated fluke. Similar reports followed. Alligators taking smaller pythons in open water, a Florida panther recorded killing a mid-sized snake in the sawgrass. None of this reverses 2 decades of mammal losses on its own. A handful of successful ambushes cannot undo what an exploding python population has done to the ecosystem's mammal base. But it does mark a change in the character of the conflict. For the first time since the invasion began, native predators appear to be probing for the python's weak points, the sluggishness after a large meal, the vulnerability during a water crossing, rather than simply being consumed by it without resistance. All of these threads are now converging in a way researchers did not plan and cannot fully predict. Eastern indigo snakes are expanding their range south, out of North Florida. Burmese pythons, tracking warmer temperatures and the waterways that connect the southern wetlands to the rest of the peninsula, are creeping steadily north. Sooner or later, those two ranges are going to overlap. Nobody has ever documented a full-grown eastern indigo encountering a full-grown Burmese python in the wild. The indigo has proven it can kill venomous pit vipers many times over, using speed, jaw strength, and a refusal to let go once it has a grip. Whether that strategy holds up against a constrictor that can outweigh it by 40 pounds or more is genuinely unknown. There is a darker complication layered underneath that question. The lungworm parasite is spreading north through the same native snake populations the indigo depends on and will inevitably interact with as its range expands. If the indigo's southward expansion runs into heavily infected territory before scientists understand why cottonmouths seem resistant and other species are not, 50 years of careful, patient conservation work could walk directly into a threat it has no evolved defenses against, arriving at precisely the wrong moment in precisely the wrong place. What the footage out of Big Cypress actually revealed was not a tidy victory and not a final collapse. It was something messier and in its own way more interesting. A battered ecosystem groping toward a new equilibrium through several overlapping fights at once, an invasive giant that is still winning by raw numbers, a microscopic parasite that answers to no species' interests but its own, an ancient native predator clawing its way back from the edge of extinction, and the everyday animals of the Everglades, after 20 years of simply being erased, starting, in small and uneven ways, to fight back. The bobcats are adapting. The eastern indigo is breeding in the wild again for the first time in half a century. The cottonmouth may be sitting on a biological answer nobody has decoded yet. None of it guarantees anything. The python population is still enormous, the lungworm is still spreading, and the outcome of any of these unfolding collisions remains completely open. That more than any single dramatic clip is what stopped the room when the trail camera footage first played back. Not a monster and not a miracle. Just a swamp that refused to follow the script anyone had written for it, and a group of scientists realizing all at once that they no longer know how this story ends. It would be easy to file all of this away as a strange, self-contained Florida story, a cautionary tale about exotic pets and hurricane luck. But the pattern playing out in the Everglades is a preview of something ecologists are watching unfold in warming, human-altered landscapes around the world. Invasive species rarely arrive alone. They bring parasites, diseases, and altered behaviors with them, and those hitchhikers can end up reshaping an ecosystem just as profoundly as the headline invader does. The lungworm did not need public attention, funding campaigns, or hunting competitions to spread. It moved through cockroaches and frogs, silent and unglamorous, while all of the resources and media coverage focused on the snake everyone could see. At the same time, the eastern indigo's slow return is a reminder that ecological restoration rarely happens on a dramatic timeline. It took 5 decades of unglamorous groundwork, buying and restoring longleaf pine habitat, rebuilding gopher tortoise populations one relocation at a time, running a captive breeding program with no guarantee of success, before a single trail camera finally captured proof that it had worked. Conservation successes like that almost never make headlines while they are happening. They only become visible in hindsight, usually because someone happened to be checking a memory card on an ordinary afternoon. Field teams across South and Central Florida are now tracking several open questions simultaneously, and each one could tip the balance of this story in a different direction. Wildlife agencies continue expanding python removal efforts, refining detection technology, and studying whether the snake's apparent behavioral shift away from human activity is a temporary response to hunting pressure or a more permanent adaptation being passed down through generations. Parasitologists working with the Snake Lungworm Alliance and Monitoring Network are expanding their sampling into new counties every year, trying to map how fast the lungworm's range is growing and whether it will eventually cross state lines into Georgia and beyond. Herpetologists overseeing the eastern indigo reintroduction are watching whether this year's wild-born hatchlings survive to adulthood and reproduce themselves, which would be the real test of whether the population can sustain itself without continued human intervention. And a small group of researchers is quietly trying to understand exactly what makes the Florida cottonmouth resistant to a parasite that is devastating almost everything else around it, aware that the answer could matter for species well beyond Florida's borders. None of these threads exists in isolation. A change in python behavior affects how far north the species pushes and how quickly it encounters the expanding indigo population. The pace of a lungworm's spread determines whether the indigo's return happens in time or walks into a trap nobody can currently prevent. And